Hi, my name is Michael Hansen, and in this video I'm going to address one of the top arguments I have found that flat earthers use to prove or to show that the earth is truly flat. I know I have not done videos of this sort in a while. There's a perfectly good explanation for that. You can see it in, I've made another video tonight where I address something about gravitational lensing and multiplane lensing. I have explained in more detail why that is. Just to make a short announcement about it. I had been fed up by being a part of multiple flat earth groups, one English speaking group and several Danish. The reason why I got fed up with the English speaking was that I found it to be either flat trolls or, well, to be perfectly honest, stupid flat earthers that kept posting the same stupid memes again and again, and I could reply the same answer again and again. And so I found with myself that when I entered this group, I would say, well, they write in the group rules that some degree of personal insults is accepted. But I thought with myself, well, I'm trying to put forth a good debating environment. So I'm not going to insult people. I'm going to try to answer them the best I can. That was my philosophy, and I still find it to be a good philosophy regarding these things. I just found that it didn't hold, because at first I saw some memes, and then I said, well, this is an example of a misunderstanding of physics, and then I gave I think with myself, a reasonable, good, detailed explanation for what was wrong with the meme, and then other memes came. And then some time went, and then those same stupid memes came back again, and after some time, I just got annoyed. And I began just saying to people, come on man, you're stupid, look at it, it's wrong, right? So I fell in with both feet, just fell straight into the ocean, the way I really didn't want to do it. So, there came a point when I just said to myself, I'm not going to be a part of this anymore. So I resigned from the group, or erased my membership. Then there were the Danish groups. They are defined as such that there's a lot of flat earth groups for flat earthers, echo chambers if you will. I have been kicked out of them just as many times as you can think. I began to reply to people that this is wrong, let me explain you how the physics is, got kicked out. Then there was a group where people just came up with the most absurd conspiracy theories, and at some point I just said to people, to a person in Danish, please stop with that conspiracy crap. Kicked out. And so it went on. Now I'm a member of, I think, 3 groups. One that I made myself for mostly globe earthers. Another where I think that there are mostly globe earthers, some flat earthers perhaps, and one group for globe earthers that another has made. So the thing was, I wanted to distance myself from this topic, because I honestly found that flat earthers were not capable of making compelling arguments. It was the same crap that came up again and again and again. I just thought, I won't be a part of this. It's really a waste of my time. But now I have distanced myself a little bit from it, and then I'm going to address some certain topics here on my channel for you to enjoy, or whatever you want to do with it. Alright. So one of the key arguments from flat earthers, at least as I have found, is perspective. So what is the idea of perspective? Well, as you all know, when we look at the sun, let's just draw a little Earth here. We have the sun here, and a little while later we have the sun here, and we have it here, then we have it here, and we have it here, and then it's set, roughly like that, right? And then it's gone here. So the globe Earth explanation is that the sun is actually fixed, and it is us that is moving. So like if I hold this pen here, tilt my head, and then slowly turn my head, at some point the pen would be out of my view. It's not exactly how it goes on, but it's a fair approximation because we have the horizon to account for. It's actually the horizon, not our eyes, but the horizon that limits how much time we can see the sun. So the sun is fixed, and because the Earth is rotating about its own axis, we will see the sun go above the sky like this. The flat Earth explanation is that it is due to perspective. As we all know that if something is close to you, it has a certain size, and then as it goes further away, it becomes smaller until you cannot see it anymore. And that's the flat Earth explanation. There are many problems with that explanation. For one, if you look at the sun using a solar filter, then you can see the true size of the sun. You will notice that as the sun rises to the sun sets, it has the same size. If you were seeing the sun disappearing because of perspective, the sun would be very large when it was close to you and very small when it was further away from you. Also, the sun would never truly disappear. So, and that's what I'm going to show in this video. I'm going to make a mathematical and sort of also a qualitative argument for it, is that the sun would diminish in size, angular size we see, but it would never disappear at all. And also the idea of using atmospheric refraction or something like that, disturbances, doesn't work, because we can see the stars that are much further away and goes through all the atmosphere that you have. But this is a completely different discussion. Maybe for a future video. But perspective. So let's take the qualitative explanation first. So let's say I'm standing here, and just for teasing, we're going to say on a flat plane. If I looked at a tree here, no, a pole. Let's just take a pole because that's easier. That pole would have a certain angular size alpha. If I move that pole to here, same height, but change the difference, change the distance. The angular size alpha 2 would be smaller. If I move the pole all the way out here, the angular size, let's say like this, here, alpha 3 would be even smaller. So if we were to write it out, we would say that, let's just call this alpha 1. Alpha 1 is larger than alpha 2, which is larger than alpha 3, and we could say that alpha x. So you can say that no matter if you kept moving this pole further and further away, alpha would be smaller and smaller and smaller, but alpha would never be equal to 0. So that's the sort of the qualitative explanation. And if you think about it, it makes good sense, right? So the flat Earth explanation here is that the angular size of the sun as it moves further away, because the idea is for flat earthers that we have the flat Earth here, and then we have the sun moving around in sort of a circular pattern. Let's put in some countries like this. Should we give it a thickness? Like this. Alright, so the idea would be that the sun would sort of move around in a circle around us. So if we were to look at the sun, it would come sort of like this all the time. The problem is with this explanation is that the angular size of the sun would never ever be zero. And in order for the sun to truly disappear, at least as a light source, would be that the angular size of the sun had to become zero. Because otherwise we would see the light from the sun. And then they have all sorts of crazy explanations of a sort of a lamp-shaped sun or something like that, a spotlight sun, whatever you want to call it. The problem with that explanation is that they have no physical explanation of why it is so. It just is, because God created it, or whatever it is. Alright, let's move on. So there are some mathematical explanations of perspective. There actually is a mathematical definition of perspective. I'm not sure I know it, but I have found an explanation I think that most people, at least people that have taken high school entry-level mathematics, would be familiar with, and that is the tangents rule, or tan rule. Not suntan, but yeah. So the tangent rule. How's that defined? Well, let's make a triangle in a little different way. So we have us as an observer out here, looking at something. Let's just take a tree, like that. That's a tree. From that we have the angular size alpha, we have a length L, and we have the height of this tree h. So from this we say, well, the tangent rule is defined as tan of alpha is equal to h over L. So if we shuffle this a little bit around, we get what we normally are interested in. We get that the height is equal to tangent of alpha times the length. So the basic idea is that if we know the length to some point, we can measure the angular size of it, we can find the height of it. Now, if some of you have smartphones, I'm not sure it's available for other than iPhone. I have an iPhone, so I know it's available there. There's a program called Theodolite, where you can actually make this exact calculation. That if you measure the angular size of something and you know the distance to it, you can find the height of it. Or vice versa. If you know the height and you find the angular size, then you can find the distance to it. This is exactly what we're talking about here. But let's reverse it. Let's say, well, in this case we're trying to make an argument about perspective. And perspective is that the angular size of something decreases as it moves further away. But fortunately for us, this is also reflected in that definition of tangent. Let's just put a box around it. See, this is important. So how do we calculate that? Well, we use something called the arctangent. So we say that alpha is equal to arctangent of h over L. Alright, so let's say the height of the tree, we know that to be 10 meters. Let's find the angular size at L equals 1,000 meters. A kilometer. Or a little below a mile, I think it is. Then we get alpha is equal to 0.57 degrees. Alright, let's try at 5,000 meters. Then we get alpha is equal to 0.12. Let's take at 10,000 meters, 10 kilometers. Then we get alpha is equal to 0.06. Let's take at alpha, let's take L equal to 50 kilometers, 50,000 meters. Then we get alpha is equal to 0.01. I'm just going to do something, hold on, because you probably know that we can convert degrees into arcseconds. And 1 arcminute is 1 degree is 60 arcminutes, and 1 arcminute is 60 arcseconds. So 1 degree would be 3,600 arcseconds. So we can calculate how much this is in arcseconds. Let's say 0.57 times 3,600. That is 2,052 arcseconds. Let's do the same with 0.12. That is 432 arcseconds. Let's take 0.06. That is 216 arcseconds. 0.21. That is 36 arcseconds. I can't remember the exact limit of the eye in ability to resolve something. But let's, for argument's sake, say that the limit of the eye, put it up here, would be 40 arcseconds. So anything below 40 arcseconds we wouldn't be able to resolve. So a pole, a 10 meter high pole at 50 kilometers, in this case, we wouldn't be able to see that. It would disappear. But if it had a powerful light source on it that could reach us, so it's not dependent on our ability to resolve it, it's simply a matter of how powerful the light source is. If the photons can reach us enough for the eye to detect it, right? But the sun is a pretty powerful light source. So if you put a light source on that pole, we would see the light source, even if we weren't able to resolve it. And you can check that for yourself if you drive cars, if you have a driver license. Because when you see at night, when you see an opposing car coming towards you with the lights on, you will initially see it as one light source. It will be a single point. And then at some point when your eye is able to resolve, those light sources, you will see it as 2 headlights instead of 1. So that's the same idea here. So even if the car is so far away that you can resolve the light sources, the headlights themselves, you can still see the light from them. Alright. But the idea here is, and I'm not going to write this strictly mathematical using limits, but the idea with this calculation here, as you can see, we are going further and further towards 0, is that as L goes towards infinity, alpha will go towards 0. But the idea of this statement is that only if L becomes infinity will alpha become 0. So no matter how far away you move something from us, the angular size will never become 0. And that is something to remind you, because one thing is that how much our eyes are able to resolve. But what happens if we use aids? Not aids like disease, but tools, right? So let's say that what our eyes are able to see is within this box. So we have a person here, and a tree, and let's say a little tower. So now I'm interested in this tower, so I use a tool, right? And many of you are probably aware of zoom lenses. Something like this, a zoom lens, right? So what happens when you zoom? Well, where is it? Unlock. So we have some millimeter denotions here. So at 70 millimeters, it's like this. At 100 millimeters, it's like this. 135 millimeters, 200 millimeters, 300 millimeters, which is the max for this lens. It's a Canon 70-300 millimeter lens, not an ES, but sorry, not an L lens, but a pretty good lens. So one way of seeing such a lens, and this is I think the usual way of seeing it, is that you enlarge something, make it bigger. But what actually happens is that you make the field you're using, the field you're seeing, smaller. So let's say I use a particular zoom lens to get a field like this, right? So now if I blow out to the same size, roughly, my tower would look something like that. So let's say I use another zoom lens. What I actually do is, and that's why you have these numbers on the lens, is that you increase the focal length of the lens. And when you increase the focal length, you narrow in the field you are watching. So you sort of get a narrow field on the same amount of pixels, roughly. So let's say this is at 70 just millimeter. So let's say this is at 150 millimeters. Then I zoom in further. Now I see the tower like this. And then I use a zoom lens. Let's say this is at 200 millimeters, roughly. Then I really zoom in like this. Now I know I've misplaced the box a little, but let's just say it like this. And let's say this is at 500 millimeters. So this means that if my eyes were having a focal length equivalent of 70 millimeters, this is not, I think it's roughly 60, but that doesn't matter. Then I could use binoculars and arrive at 150. And then I could see more of that tower here. Then I could use a stronger telescope at 200 millimeters and see more of the tower. And then I could use a stronger, even stronger telescope or binoculars at 500 millimeters focal length and get even more of the tower visible. But what I'm really doing is that I'm just decreasing my field of view. So I am actually making my eyes, or the camera, or whatever it is, able to resolve smaller and smaller angular sizes. Now, this argument would be equally usable on the sun. So let's, for argument's sake, say that the sun has gotten so far away. Here, this is the eye. I think it's 60 millimeters, but I'm not sure. 60 millimeters effective focal length. So we have the sun, and it's disappeared. So we have the ground here with some trees and so on, and the sky here. Alright, so the sun, which was initially here, has disappeared into the flat earth sunset because of perspective, and I can no longer see it with my naked eyes. So I take out some binoculars and I zoom in on this field here. Lo and behold, what I should see would be a small sun. Let's say this is at 120 millimeters. So now I take out my zoom lens, and then I use all the power I have. It gives me this field, which is at 300 millimeters. And because my camera is not a full-size sensor, but it's APCS or APS-C, I can't remember what it's called. I think it's something like 420 roughly effective focal length. I would see the sun like this. And this means that as the sun goes further and further away and becomes smaller and smaller, I could get it back into my view by simply just increasing my focal length or narrowing my field. And this is simply not the case. First of all, the sun doesn't become smaller when it sets. It has the exact same size, it goes below something. Or disappears bottom up, if you will. That cannot happen with perspective. Perspective makes things equally smaller in all directions. Nothing can disappear bottom up like that. And that's also a problem with the perspective in general. When we, for example, talk about boats. So several arguments has been proposed that if you look over at the ocean, you could see a ship or a boat like that. You might even just see the masts, and you might see another boat like that. So if perspective were the case here, that would never happen. That would never happen. What would happen would be that, let's make the flat earth ocean. We have a boat here. Then we have a boat here. Then we have a boat here. And then we have a boat here. That is what would happen. The boat, the bottom of the boat would never ever not be visible. So I think I would say now that I have given a reasonable, compelling argument, both qualitatively but also quantitatively, why perspective could never explain the observations that we see. What we see is that buildings, ships, the sun, the moon, even stars, galaxies, they disappear like this. Sorry, like this. So the bottom disappears first. The sun disappears first with the bottom. It is round, then it's a half shape, a moon shape, and then it's a little tiny blob, and then it's gone. The moon does the same. Stars are a little different because stars are points of light, so they just are there and then they are not there. But still, the way they rotate, you can see the way the stars move on the sky. They disappear below the horizon. They don't go out of view. Now I know that flat earthers has a different argument for stars, but never mind. The moon, the sun, both disappear below the horizon. They don't just vanish into a tiny dot and then you cannot see them anymore. So that is why I say that the perspective argument from flat earthers don't work. I know there are people out there that has approached this problem in a different way, using, for example, Snell's law or something similar. But I just used the tangent rule to show just basically that you can never arrive at a place where the apparent angular size or the angular size of an object becomes zero. And given that if you have a point, a light source, where the angular size becomes so small that our naked eyes are no longer able to resolve them, we would still be able to see the light. So even if the sun could go so far away that our eyes couldn't resolve its angular size, we would still see it as a dot of light. Alright, so thank you for watching, and I hope you will return when I make another new video. Hopefully, I think. Bye bye. Oh yes, just back again. I just forgot to say something not terribly important, but still I wanted you to know it. And that is, in the future, I'll try to see if I can find either some blue paper or some green paper to fill out my whiteboard here, or at least a part of it, to make, in order for me to experiment doing what is called a chroma key, or blue screen key, or green screen key, in order for me to be able to show you on this blackboard drawings that you can actually see what it is. I probably will still make some formulas and use my trusted pens here, but I think that we will all be happier if I could show you actual things on the whiteboard here, some actual pictures in this size here, so you can check it out. So, for example, something like this or this, I can show you like this, and I can point to it at my best because I cannot see what's there. But I will experiment using chroma keys in Adobe Premiere Pro, and then we will probably get you will probably get some better videos, hopefully. So that was it. Bye bye.